My name's Keith Babo. I'm a product managing director at Red Hat. My primary focus is on integration. Today, I want to follow on some of the talks that we've already heard today, specifically around distributed integration, agile integration, and talk about some of the patterns and kind of an API-based approach to realizing agile integration. I normally have a sort of involved demo, and there's a good news, bad news thing there. The good news is that my slides are all on Google Slides, so I can do those from Christian's computer, and what I'll be demonstrating is our iPad solution. So that's all running in the cloud, so the cloud is still safe, even though my computer obviously is unhappy. But there's a developer portion of it where I write some code and push that in, and I don't think I'll be able to do that today, so apologies there. I guess if I didn't mention anything, you would have never known it was missing anyway. Okay, so let's get rolling here. I like to start talks with like these big number things that I find pretty scary. I don't know if other people do. But a couple years back, Gartner predicted that by the year 2020, which is only a year and a half away, we'll have approximately 26 billion connected devices, right? With 215 trillion stable connections, right? So that adds up to kind of like, or those connections are making 63 million connections per second. So what's interesting, there are a couple of interesting things about these numbers. First is that they're really big, and they include a lot of IoT stuff, right? So these are, toasters and hospital rooms and doorways and, shopping carts and all this kind of stuff, right? So maybe not directly relevant unless you're an embedded device developer, maybe not directly relevant to you, but if you get within 1 or 2 degrees of separation from these devices, you're talking to an IoT gateway or a back-end service that's processing this information. And those are going to be based around APIs. And so I like to point out these numbers because they're kind of emblematic, building on what Samir and Steve said earlier, is that it's not just a revolution from a developer standpoint that we're doing more APIs for microservices or whatever. Like the entire world is moving to APIs, and they're doing it at a scale that, even individual developers just hacking up a microservice, like way beyond that scale. Every device gateway out there is going to have an API and integrate with APIs. So if we accept that just APIs are really taking off, it poses these sort of existential questions for us as IT folks, that people are creating more APIs. What is your plan for consuming those APIs? We used to be able to write applications, and they're pretty siloed. You run them on a platform, they maybe talk to a database, you throw up a web page and this kind of thing. But more and more, whether it's because of microservices or because vendors, like SaaS vendors, are throwing up APIs, or any other number of reasons, our applications have to interact with other applications through APIs. So the rate at which we're consuming these APIs is really going up. And it's crossing a lot of interesting boundaries. So if you look at like public sector type of firms that might be doing like fair housing type of applications, right? They have a registry of affordable income type of housing for citizens. Users will start, they're getting conditioned to having information like on the internet through sites like Yelp or LinkedIn or whatever, these social networks, that all of these data stores are interconnected, right? And so when they go looking for this, they might want to see reviews, not only like, hey, here's the list of all the properties where I can afford a house, but also what are the reviews of these and who else lives there and how do we kind of self-organize and create kind of online social settings around these. And all of those are API-based interactions. So when we go to create the next generation of our applications, we have to be thinking about how we're going to consume these APIs. Likewise, we have to think about how we're going to be providing APIs. Just in the same way we are consuming all those services, people will want to consume our services not only directly, maybe through a web-based interface or some machine-to-machine communication on the back end, but also through APIs. So how do we start to scale up to recognize that we're providing more APIs? And then speaking of scale, let's say this gets popular. You introduce an API out there and like maybe a few people hit it, but then overnight, some developer writes a mobile app, right, that starts to take advantage of your API, and it goes from 5 calls a day to 500,000 calls a day. Are you prepared to handle that scale, and how elastic is your environment to deal with that? And that's a really significant problem, even in kind of entrenched, kind of maybe more traditional industries. Like we talk to banking customers who don't have the IT staff with the mobile expertise to go develop mobile apps. What they're doing is they're just creating APIs, making sure they're secure and they're throttled. They're throwing the APIs out there, and then they have other third-party teams go and develop apps. Sometimes they coordinate with those and they contract with them, and sometimes just organically app developers do that because it makes their application better. So the bottom line here is that APIs are going to be everywhere, and it's not small numbers of APIs, it's very, very large numbers of APIs. So when we start to talk about these large number of APIs coming on the scene, we have to ask how we need to evolve on a couple of different dimensions. And the first is technically and architecturally. So in the old days, which is the current days for a lot of people too, every deployment is a snowflake, right? So we were talking about containers earlier and being kind of an environmental encapsulation, right? With containers, a container runs the same in dev as it does in test, as it does in stage, as it does in prod, right? But in the bare metal days, it's always an adventure. If you move between those environments, your application code could be exactly the same, but you could see wildly different output, right, and behavior across those various environments. And that necessarily hurts our agility and our ability to get that code into production. Another thing we see a lot is Samir was talking about ESBs and hub and spoke architectures and service-oriented architecture. A lot of these are very inward kind of focused architectural concerns. So we care a lot about what our inner architecture looks like, but we're not thinking about what that means to an end consumer. They don't care how elegant your internal architecture is, right? They care about service availability. They care about features. And so we have to change from a posture where we care about how we have service boundaries internally to how we're exposing these APIs externally and caring about the consumer. And then finally, this aspect of automation. So many of our customers have a problem that if they're going to deploy, like bug fixes, they can probably get into production pretty fast. But let's say they want to do a new version of their product, add new features. That kind of deployment happens once or twice a year. And there's so many reasons for that. It's not just the speed of their development team, it's the relationship with vendors and outage windows and a whole other host of factors. But institutionally, they've now conditioned themselves to my business, right, and my product gets better once or twice a year. And that's not the frequency that you're going to need to be competitive moving forward. So these technical architectural constraints are holding us back at this stage, and a new strategy is required. And another dimension of this is organizationally. So we talked a little bit in the panel about organization of teams and their ownership of various things. And so we see with microservices teams now that there's very much this orientation of ownership. I wrote the code, I tested the code, I deployed the code, I carry the pager and I support that code, all right? How likely is that individual to look outside his team for standard architecture? How likely is that team, a developer on that team, how likely is she to go out and ask for best practices from other teams? Not very likely, right? They absolutely should, but this concept of ownership starts to kind of create these silos of individual deliverables. Another aspect of this is that if you look at within IT, there's the kind of hardcore developers, integration experts, architecture experts, but there's also groups that are aligned to line of business, like marketing or finance or other types of, or sales. And these teams are starting to find that that they can actually go out and acquire software directly through SaaS, right? So whether it's Salesforce, NetSuite, Workday, Taleo, all these various SaaS vendors out there. And it gets around this problem of having a huge backlog with a single team. Like there was a question earlier about expertise within an organization around integration, around architecture, and establishing patterns and best practices. And all of these things are great for an organization and absolutely needed to have a mature IT organization. The issue is if that team has to sign off and rubber stamp every deployment that happens, you end up with a huge backlog. And it sends these other teams out that have their own budget to go buy these SaaS solutions, and then they end up circumventing IT governance. So a big problem here that we have is that we've established these integration competency centers. We have the center of excellence. How do these teams remain relevant when everyone else is trying to do their own thing and cut them out of the picture? And I believe 100% that these teams are absolutely needed, right? They're the nucleus of creating stable production applications in these enterprises, but they're at risk of essentially disappearing. So those are two sort of dimensions there, the technical and architectural dimension, and then the organizational dimension of how things are evolving. And as Samir covered earlier, Red Hat's opinionated strategy for how organizations can evolve and deal with this is Agile integration. So Samir went into a bunch of detail on that. I'm not going to go into the details. What I'm actually going to do is talk about some of my experience talking to customers and in working with customers in the types of patterns they see and why an Agile conversation or an Agile integration conversation happens, right? So why might you find yourself in a situation where you're talking about Agile integration? How can you be successful with it, this type of thing? So in my experience, this boils down kind of in 3 categories. There's strategic drivers, there's technical drivers, and then there's line of business drivers. So I'll just go into an example of each one of those, and then we'll do a demo. Hopefully, fingers crossed on Christian's computer here. Okay, so technical drivers. So in this case, what you're saying, I come across this case when a development team or development manager has already arrived at a conclusion that microservices is the answer, right? Or we're going API first now, or we need to be cloud native and we need to deploy on a container platform, right? So at this point, the decision has been made. There's no higher level discussion to be had, which is fine. There's nothing wrong with that. But these teams want to know, like, what are the patterns for doing this successfully, right? If we're going to go down this path no matter what, and I'm sure lots of other people have gone this path as well, what are the potholes? What are the things to look out for? Where are the alligators and the lions? So let's drill into that specifically, this idea of like saying, I have like maybe an API first type of approach and I'm doing some microservices. So a very common pattern in the microservices community is this idea of an API gateway. Personally, I hate this name because it kind of is at odds with what in API management circles, what we consider to be an API gateway, but whatever, I'll just roll with it. So an API gateway in a microservices type of environment is this recognition that if I'm a team or I'm a group of teams developing microservices that together comprise an application. So a microservices application could consist of 10 to 15 individual microservices, all right? In that scenario, I then say I want to create a mobile client to talk to my microservices application. And I have a choice. I can say to the mobile developer that you need to individually orchestrate and talk to each one of these 15 microservices that's in my application, right? Or I can create a facade, a proxy facade in front of it that actually hides the fact that there's 15 individual microservices, and it presents a single API for that mobile client, okay? So that's the API gateway pattern, pretty straightforward. So what I want to do is, like, and especially like in books and stuff, this pattern just seems super clean, it's super easy. I'll go in and polyglot, somebody does this, Christian described, somebody does Perl, somebody does Vertex, somebody does Python, whatever, right? And everything's great because it's all greenfield. And when you talk to customers about this and they go down this path, you start to like peel the onion and start to understand that there's a lot of other concerns. So let's talk about some of those if this is the type of thing you might end up doing. So the first point here is that even if you're doing greenfield microservices development, you need some basic integration capability. So a common concept in microservices is this idea of data ownership that comes from domain-driven design. So they have this concept of a bounded context, which basically means that your data means something to you in your specific context, and it's yours. You own it, you control it, you define the model. That's totally awesome for that microservices team that's developing that app, right? Or that service, I should say. But for the person that's creating an application of all those 10, 15 microservices, well, what if all 15 microservices have their own idea of customer or patient or order or shipment? Now you got a big problem, because when you go to combine all of those, you have to account that this one has this field, name is limited to 10 characters in this version of it, but not in the other, right? People name the same field different things, all these classic data issues that you have in integration. And so we find that a lot of times, even just full greenfield app, all contained within the same platform, you have this really strong need for data transformation, routing, and aggregation, right? And that's like kind of the core lifeblood of integration right there. And you don't want to go write that on your own. There's a very popular frameworks out there, Apache Camel being one of them, that does exactly that type of thing. So first thing is that even the greenfield apps require some level of integration. Second point is that I have not come across a customer or a situation where everything is greenfield. Even if all the development is new, the data is old, right? It's not like you write your microservices application and then you have new data all of a sudden that all is resident on that platform and it's good to go, right? you're talking to all of these, customer repositories, accounting repositories, all these back-end services that have their own data, and you need to go connect to it. And it's not always pretty to go get it. Not all of them have REST APIs, right? So you're doing JDBC, you're doing batch, right? You're doing SOAP-based web services, maybe RPC lit kind of stuff, like some really, really nasty stuff to go get this data, okay? And so there's this big problem now that inside your microservices architecture, everything's super nice and everybody's talking a REST API, or maybe you're really advanced and it's some kind of like, event trigger CQRS kind of thing. But as soon as you go to talk to where your data actually resides and the whole purpose of this application, now that all breaks down and you're back in the kind of muck of the legacy. So the next thing that you need to keep in mind is how are you going to connect and deal with that data outside. So you need some pattern for doing that. And a very common one is to say, let's use some more integration with connectivity to talk to those backend data stores, and we'll expose that via REST API. So all of my microservices inside of my architecture still talk REST APIs, everything's cool, but I have these smaller integration services that just handle connectivity. Then finally, this is normally once the application gets deployed and you start getting some experience with it, you're like, this is working pretty well, but as Christian demonstrated with Istio, you start to realize at scale, at some level of availability and trying to guarantee that these services have uptime, they're sort of resilient, that there's these cross-cutting concerns that start to apply. That say like, well, what if my service does get really popular? Like, how am I rate limiting consumers, right? Or is that something that I do based on the type of client? Like some people can invoke it a certain number of times, premium customers can do it more. What is my security posture? Is this just open to everybody? Or do I have some type of a security, whether it's basic or OAuth or whatever? How do people discover these APIs, right? And how do I engage with developers so that they can self-register? How do I actually even understand what popular APIs are? How am I doing analytics? All of these things will apply. If you have 15 API-based microservices, you're going to want to deal with these concerns across all of them, right? So you have to start thinking how you cut that layer out and handle it in a more systemic way than repeating that in every single microservice differently. So at this point, after all these things are concerned, the picture starts looking a lot more like this. Oh, and I get to use this cool flashlight feature. Let's try this. Yes, that's so cool. How does that work? Okay, so there's our original mobile client that we talked about, right? And so we still have this kind of concept of the initial API. We're just exposing one API. But in this case, it's an API proxy, which is the data plane for our control plane up here, which is API management, right? And at that point, I can handle in one place, right, through a self-service portal, things like security, throttling rate limits, analytics, monetization if I want to charge for the APIs, right, engagement through a developer portal. All of that's handled in one place here. Behind that API, oh no, I'm obviously not as experienced as Christian using the flashlight feature. Let's see, let's try that again. Okay, cool. So behind that the API gateway, now you have your individual integration APIs. Those are doing basic routing between your microservices. Those might be doing some basic transformation if they don't agree on models. And then you can have separate integration APIs that deal with back-end data. And these can actually be purpose-built, like their job is that they're an integration microservice, or the integration components can be built into your existing services. I can't remember, Christian made the point on the panel that we're starting to see this shift between people that always self-identified as integration developers or application developers as now just being developers. And they need a little bit of integration and they need a little bit of application logic. And that's what's going to happen in the kind of microservices world. Okay, so that was a technical example. Let's talk about strategic drivers. So strategic drivers happen when your senior leadership team goes to an offsite in a beautiful location, right? It's by the beach. Everybody drinks lots of fancy wine. They use all your expense budget for the year. And they come back and they say, we're going to be the next Uber, right? Or we need to move faster. Or 2 years we're going to be in the public cloud, right? And so none of these are bad things, right? It's great to move faster, to be more competitive, to kind of be this, this disruptive influence in your industry, right? All of these are great things. The problem is that, just saying them, it's meaningless, right? So we have to say, like, not only, now that's a great goal to get after, right? But how do we define an architecture and approach to actually realize that? And then how does that kind of percolate down to a technology standpoint? So let's zero in on this idea of cloud adoption, which I think is super important. And one of the things that people stumble on the most, okay, when it comes to these strategic options, and because every customer I talk to has some kind of cloud strategy, right? Even if it's like avoid the cloud. There's a cloud strategy for everybody. And so Maureen was talking earlier about how cloud adoption, if you look at who's running or has some workload running in public cloud, has now moved into the mainstream, which is pretty striking, right? So it wasn't, now we're talking about the majority of people here, but it's like 52%, right? So there's still lots of people that don't have that posture yet. But that's a lot of people. Pretty soon you're gonna be in a more significant minority when you're not in the public cloud, and then at some point you're completely marginalized, right? You can't be competitive anymore if you don't have that kind of posture. And that doesn't mean you're all in, but for some amount of workload, for fast-moving apps, you know, whatever, you're in the public cloud. Now, if you dig into those numbers a little bit more, you start to see something more striking just about than the absolute numbers of how many people are there. What you find is that when a company starts to look at cloud, right, and they maybe start with just one POC or an initial deployment, maybe private cloud, they get a taste for it and things start moving fast, right? And so the important thing to realize here is that once you start going this direction, there's not going to be a lot of time to re-architect on the fly, to question your decisions. You're going to arrive at a platform, you're going to start deploying. People are going to like the idea that you're deploying faster, that you have automation, and now everything's going to start rolling onto that platform. So you really have to think about the long-term concerns around how you're going to adopt that platform, not just now in the private cloud, but how you're going to have cloud portability, how you're going to move to public cloud eventually. Another big concern that everyone forgets, and this is a great thing to bring up in meetings when people are going on and on about the cloud and blah, 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 is that the cloud is necessarily hybrid and a composite of these various environments, right? So it's not just the fact that it's, you know, private, public cloud that's self-managed, public cloud that's vendor-managed, right, in more of a SaaS type of environment. It's also that the data is all over the place. Even if you look at companies that are 100% public cloud, right, that are almost purely SaaS-driven, right, their entire back office is SaaS, they're not running one SaaS product, right? They're running probably 6, 7, 8, 10 individual SaaS products. SaaS vendors don't share data. So guess what? They still have integration, and they need to integrate the individual data lakes between all of those SaaS offerings. And that's just for the people that are purely in public cloud on SaaS. For the people that start to incrementally invest in SaaS, they have a problem of getting on-prem data into that SaaS offering and then vice versa. So it's something absolutely to think about and to strategize about. And you know, this is a conversation that I find that a lot of our customers, like, it's something they want to get ahead of. It's something where they start to show leadership internally when they start to bring up these concerns, because people view it more as an infrastructure thing than a kind of holistic application integration picture. And when maybe you bring that up and you start to propose, and people say, well, what do you think we should do about it, right? One of the key things here is to understand not only that you need this ability to move between clouds. So I brought this up earlier on the panel, and I think some others did as well, that you want to adopt an architecture that works in private cloud now, but can go to self-managed public cloud on a number of vendors. So having a truly hybrid cloud offering that you're not re-architecting if you move from Amazon to Google or to Azure, right? So you not only want to be able to lift your workload and get it into a public cloud provider without redoing it, you want portability between those clouds. And you eventually maybe want the ability to actually have the vendor manage your environment, and you just do some development and they manage all the infrastructure and containers underneath you. So it's super, super important to have that flexibility between environments and vendors. But the other thing is the tool chain that allows you to integrate all that. So whether that's creating your containers, deploying your containers, integrating between those data silos, that becomes this kind of cross-cutting across all that you're going to have to establish that plane of management on your own and look to platforms that provide one that's not specific to a specific environment or a specific vendor, but cuts across all of them. Okay, final one is this idea of line of business drivers. So as I mentioned, the line of business user is someone that they're like somewhat technical. I mean, they understand, actually anybody in this room self-identify as a line of business user? I'm just kind of curious. All right, So these are the other people, right? The line of business users. If developers are here, these are commonly users that hand you requirements, that complain about it taking so long, right? That are attached to some business function and are interested in like, why can't I run my reports, or blah, blah, blah. So the interesting thing about line of business users is, in all of my years, and I'm an old dude, so I've been around for a while, that I've never seen this level of empowerment at this level of the business, which is that line of business users always had the budget, and they would hand it over to IT and say, okay, go buy, whatever, the ESB or whatever you got to buy to make this problem, solve this problem for us and make us live. But now with SaaS, they don't need to hand over that budget anymore, right? They can sign a PO. They don't have to install or configure anything, right? They have come out, the vendor does a POC, and now they're up and running in the public cloud. So this team now has tremendous power. And going back to this idea of the ICC or development teams staying relevant, you have to demonstrate that you can talk to folks in the language that they understand, accept that SaaS adoption is going to happen, and have a real organized plan for how that's all going to work together. So I think that our relationship between these teams is starting to change in probably a good way. It's challenging the status quo. But I've seen a lot of kind of disastrous situations where teams with budgets go adopt SaaS, ignore integration completely, and then it basically shuts everything down. And it's a big emergency when they realize that the cloud-based systems have to talk to the on-premise systems. So anyway, so let's explore this idea of self-service a little bit more, and this idea of bridging populations and having people collaborate. So the example I like to use is I try to think up like kind of basic. These users that like aren't technical necessarily, aren't developers, they understand business data, they understand business processes, and they don't want to write code to solve integration problems, right? So they are typically using maybe a web-based UI, it's a completely cloud-based solution. A lot of times in the industry we call this iPaaS, or integration platform as a service. When these users think of problems, the type of user is someone like, let's say I worked in a warehouse, which would be bad right now with a broken collarbone and a broken toe. So I might say like, hey, I can't lift any boxes right now, so I need to think of another way to add value to my company. So let's imagine you work in a warehouse and you get trucks delivering boxes of stuff. And of course, sometimes the boxes drop, the vendor ships you something like the product that's no good, but there's damaged inventory, right? And of course, someone, when they're in receipt of that inventory, they're always recording what happens in terms of, like unpacking it and saying, okay, this is damaged or this is good. So you have a feed of that data. But right now that data, it's very manual, like maybe someone writes it down, there's no automation of it. So if you had a feed of that data, maybe coming in through a message queue, and your company had some type of task automation software, like a to-do list, basically, that maybe had a REST API, you can start to see in your mind, like, well, we have the data that's coming in that's actually reporting damaged inventory, and I have a place where I could actually record that and have somebody act on it. Can I connect these two dots, basically? Can I get this data from this message queue into this task management application that has a REST API? So that's kind of a common kind of self-service integration example. So now I'm going to try to use Christian's computer for a little demo here, maybe spice things up. So if this doesn't work, it's Christian's fault. All right, got that out of the way. This little touch bar is super cool too. Okay, so here we are. Yay! All right. So let's talk about what we're looking at right now. So right now I'm looking at a brand new offering in the Fuse family, in the Fuse product family. It's called Fuse Online. So this is completely cloud-hosted, 100% web-based experience for integration. And right now I'm at the dashboard of this portal, this integration portal. And if I come over here and I look at the connections, I can see that I actually have an AMQ connection here. So this is where I'd be receiving my warehouse inventory and my damaged inventory. And at this point, what I want to do is I said I wanted to connect to an API, right? So one of the cool things that Fuse Online provides is this idea of a generic API connector. So if I have a Swagger or an open API specification for any API, I can generate a connector inside of Fuse Online. So if I come in here and just look at like creating a new connection, you'll be able to see that we have all these kind of, natural scroll. We have all these connectors out of the box for connecting to stuff. But in this world, we were just talking about how APIs are exploding. It's never going to be enough. We can't keep track of every SaaS app that's coming on board, of every off-the-shelf API that's going to be offered. So it's much better to have almost the universal API connector that allows you to create your own API connectors declaratively, right? So in this case, what we're going to do is, and let me, hey, okay, we're a lot closer. I might as well explain the backstory as I'm doing this. What I'm doing here is I'm looking at the to-do app that we ship as an example app with Fuse Online. We'll have a route exposed outside of the clusters because it's a public service. And I just forgot I didn't memorize the URL, so I just need to go get it. Yay, this is our little to-do app that we ship. And from that, I can get the Swagger because I think it's at this. Right, okay, so here it is. So this is the Swagger that the to-do app in our company, right, in our fictitious warehouse, exposes an API, and it's got a Swagger. So now I just want to connect to this API. All I have to do is take the URL for this Swagger, and I come back into Fuse Online, and what I'm going to do is create a new API client connector, and I just feed it this URL and say next. And we can see that it automatically registered the resource entities that are in here and the operations that are available on them. So go ahead and click next. That all looks good. I'll accept the defaults and say create API connector. If I wanted to, oh, I forgot one thing I can actually I don't want to have the icon because this is not my, so forget about the icon. Okay, I can customize this icon, but because I switched computers, I don't have the icon handy. But great, so now I've got this connection now. I can create a connection to an API just based off the Swagger. So I'll say create a connection, and then we'll come in here and say, in this big list of, there's Salesforce and FTP and Dropbox and S3 and all these very cool things to connect to. But now this new API that I just imported is available here too. So I'll select that, and I'll give it name and password, and I'll say next. And then we'll say to-do API, to-do task API repository. All right, awesome. So now my connections view, I have the data feed in AMQ, and then I have my to-do API where I want to put things. So I just want to connect the dots now, right? So I'm going to come into integrations, and we're going to say create an integration. And so now Fuse is asking me, okay, where are you starting from? Where are you getting your data from? I'm getting it from AMQ, so I'll select that. Oh, man, I forgot. There's one other thing I need now. I need the schema. Oh, no, I don't. OK, we're good. Everything's cool. Everything's under control. So from AMQ, I'm going to subscribe to messages. That's the action here. So that means I'm pulling data from a queue. The name of that queue is inventory received. And it's a queue. And I'll say next. Now, the cool thing here is that for certain types of data, like Salesforce or Twitter, it has a static object model. We know the type of data that we're going to get. In the case of a message queue, it could be any data, right? So right now, Fuse is asking me, hey, what kind of data am I getting? If I don't have to specify something, and let's say I'm just doing a pass-through or protocol bridge, I can just shuttle the data through all day long. But if I actually want to do something like data mapping or filtering or anything that's data intensive, it needs to know what type of data I'm dealing with. And I can specify based on a schema, like a JSON schema, XML schema, or I can just pull my data. So this is a really convenient feature that if I just have some sample data that's around and it's representative of the type of data I want to process, I can just grab it. And so I have exactly that right here inside of, I'm just going to trim this down for demonstration purposes to the easiest thing I can get. So we'll say this is our, oops, not that, don't trim it down that much. All right, so this is what we're doing. We'll change this just so you know it's real. We'll call it Acme Inc. So this is my sample data. I'll come back in here, and I'll use that as my instance data, and I'll just give it a name, and you'll see that come in a minute, and a description, and we'll say done. Did I actually click done? Let me try that again. There we go. OK, so now I'm subscribed. I know the data I'm getting. I wanted to push this into the to-do API, so I'm going to select the to-do API. These are all the resource entities in my REST API. I'm just going to create a new task. So I'm receiving this inventory data, and I actually want to create a task for somebody so they actually follow up on the damaged inventory. So I'll create that task, and there's nothing more to do. Now, it looks like I have, well, first it looks like I'm selecting the whole screen. So I have a little warning here, and if I click on this, it'll say, there's a data type mismatch. So Fuse is inherently type aware. So it knows the data you're receiving, because we just told it, and it also knows the data from the Swagger definition of the JSON data that's going to go into the API, and it's saying this data doesn't match. So that's kind of handy that I did that, and it's suggesting that I add a data mapping step. So I'm just going to go ahead and add that data mapping step, and I can see here on the left-hand side, I have, this is the XML data that's coming in, and over on the right-hand side here, I have a number of fields that I can map that to. In this case, I just want to map like maybe the vendor to task, create a new task. If I want to get fancy, maybe I can I'll combine some fields here. So I'll map both the vendor and the ID, and I'll separate those by, let's say, a dash. And then at the end, and I'll map those into the task field. Let's add something else fancy here. We'll say like basically a command. We'll pre-append some stuff, and we'll say broken stuff. All right, done. So I'm going to go ahead and publish that. And I'll say my to-do integration. Oops. Christian's computer is cool. All right, publish. Okay, so a few things here. So basically, this entire integration scenario was just pointy-clicky, basically, right? So I'm aware of the data. I understand functionally what I want to happen. I want to receive data from one place, send it to another, do some data transformation. We have a higher level UX and UI now that allows a user without any code to do that end to end. The cool thing is that underneath the covers, this is all the full power of Camel, right? So you're getting all the best piece of Camel, the robustness of Camel underneath the covers, but you're doing it from a much higher level interface. When we create, like if you look on the URL here, and it was actually almost, it was cool, it's almost like it was planned that my machine wouldn't sync with the monitor, because I could easily, somewhat easily, took 10 minutes, move over to the other laptop and actually just do this from there, right? So all of this that I'm doing is on our eval cluster for Fuse Online right now, 100% hosted in the cloud, not running on this machine, just the browser, basically. So not only is the tool chain running there, but when I click publish, what happened is the Fuse Online spun off a container build, and it built a Fuse on OpenShift image just for this application. So the cool thing, well, there's a lot of cool things about that. First is, again, you get all the benefits of that horsepower of it being a Fuse Online container image, so it can scale, it's resilient. If a failure happens, it'll restart the container. But it also means that if I have developers that are creating their own integrations, they can deploy on the same platform, right? So if I have a technical developer that wants to develop a much more sophisticated application, they can put those applications on the same platform and scale them in the same way and have them talk together, even with these kind of higher level integrations that I created here. If we go look in the underneath the covers here, I can see, I think I missed it because I talked so much, but I've already got a build that completed. So that was the S2I build inside of OpenShift. And then if we just go to the list of pods, let's see, our integration is running. So that's starting up right now. And this is just a Fuse on OpenShift app. So it's no different. It can move. If I develop it in the cloud and test it out and run it there, I can take that container, I can run it anywhere OpenShift runs. So self-managed public cloud, I can run it in private cloud, I can run it anywhere. That workload is totally portable. So just, let's see, we'll actually show that it works. If I come in here and I send this JMS message, what should happen is if I refresh, I should see, yep, broken stuff for Acme, right? So it all kind of tied together. All right, let's go back. Now, unfortunately, because I don't have my IDE on Christian's machine, strangely enough, I won't be able to show, well, I'm going to show this animation again because it's a cool animation. So I won't be able to show another really cool aspect of this, which is that I just showed this line of business user that doesn't want to write code solving this problem. But what can also happen is that developers can go and just using Fuse and Camel write their own routes and contribute those to Fuse Online as native extensions. So that means if you get to a point where this line of business user, this non-developer, can't solve a problem, you need to really write some code to get in there or write a Camel route to really do something sophisticated, developer can still do that. They upload the jar file to Fuse Online, and then that's just another step in the flow that this user creates. This collaboration between these two people is a really important thing. It allows everybody to do the thing they're most productive at. Line of business users pointing and clicking, developers writing code, not writing code to solve boring problems that anybody could do, but writing code to solve real problems that they should be working on. So a key aspect of collaboration there. So I got like the 5-minute warning here about 4.5 minutes ago, so I'm going to rush through this last bit here. To follow on something that Samir said, when you talk about agile integration, one of the pillars was distributed integration. From a Fuse standpoint, what's really important to us there is scaling on 2 dimensions. The first is integration wherever you need it. Some people are embedding integration in a WAR file, deploying it on Tomcat. Some people are Java E shops or OSGI shops or Spring Boot shops, and they want that runtime there. Some people are doing microservices and container native integration inside of OpenShift. We support, no matter where you want to put that integration, we support all of those runtimes. So if you look at investing in Fuse as a technology, you know that it's not going to be a dead end if you come up, I need it containerized, I need it running in Java EE, I need it running in OSGI, wherever. The other aspect is that, so that was one dimension, almost like the x-axis of how much you could spread that integration around. The y-axis is who's doing the integration. Classically, Fuse has been a developer technology, so developers come in and it's a very powerful platform for developers. Now the same platform continues to be powerful for developers, but people that don't want to write code can be highly productive on the platform as well. So really starting to expand the scope of the platform overall. To back that up, Fuse 7, which will come out next month, we'll have 3 distributions, so it's a single product, but Fuse will support standalone, which is Fuse running on a single JVM, Spring Boot, embedded, EAP for Java EE, or Carafe for OSGI. We already run Fuse on OpenShift. We'll continue to support Fuse on OpenShift. We've done a lot of enhancements there, really cool stuff with Fuse on OpenShift. And then Fuse Online, which I just showed you, will also be available with Fuse 7 GA. If you wanted to try that out yourself, we have an eval cluster up. Anybody can go and register. You get a free 14-day trial. This is the URL you use. We'll distribute the slides after, so you're welcome to try it out. If you click that red button, I promise I'll click the approve button, and you'll get an account, and you can kick the tires and let us know what you think. That's it.